So far, we've seen two methods of solving systems of equations. The first method was graphing. The second method was substitution, and now in section 6.3, we're going to look at the elimination method. We're actually going to do the elimination method in two different parts. In section 6.3, we'll look at more simple problems, and in section 6.4, we'll dive into more complicated problems that can be solved using the elimination method. So let's just jump into it with example number 1. Solve the system of equations by elimination. So when you hear that word elimination, you literally think of canceling out, eliminating each other. So that's exactly what we want to do in the elimination method for solving systems of equations. The first step is to make sure that everything is lined up, meaning we want the x's on top of each other, the y's on top of each other, the equal signs on top of each other, and the constant terms on top of each other. These equations are also in standard form. If you remember back from a few chapters ago, standard form is when you had something like this, something x plus something y equals the constant term c. So again, these equations are in standard form, but really, as long as everything's lined up, you can still do these problems. So again, when you think of elimination, you want them to eliminate each other. So I'm going to look for opposite coefficients in front of similar variables. So when I look here, this x has a -3 and this x has a -1. -3 and -1 are not opposites of each other. When I look at the y's, this y has a +1 coefficient and this y has a -1 coefficient, which 1 and -1 are opposites of each other. So what we want to do is eliminate them. And we do that by adding downward. So we are going to draw a line under both equations and say plus. So what we're going to do is add downward. So I'm going to take -3x and -x, add them together, and I would get -4x. When I add the y and the -y, those would cancel each other out since they have opposite coefficients. That's the elimination part of the elimination method. So the y's are eliminating each other. They're going away. And then I would have equals, and then I'm going to add the 5 and the -1, which is equal to 4. So now notice I can solve for x. So I would divide both sides by -4, and I'd end up with x equals -1. But just like in the last section, we always want to answer these as if we graph them, meaning we want to find the place where the two lines intersect. So we need to find the y value. If we know that x is equal to -1, we can substitute -1 back in for x into either equation. To me, it would make sense to put it into this equation since it's a positive y afterwards. So then all I got to do is basically add that number over or subtract it, and I would get y by itself. So to get y by itself, I would first take the -1 and substitute it in for x. And again, if I did the other equation, I would get exactly the same answer. It doesn't matter. So -3 times -1 is +3. So then I would subtract 3 from both sides, and y equals 2. And again, if I had chosen to substitute that -1 into the second equation, I still would have gotten y equals 2 for the y value. So again, answer it as if we graphed it. So what this is saying is if I would have graphed these two equations, this is where the two lines would intersect. If I plug -1 in for x and 2 in for y, I will get a true statement. Let's look at another example. Solve the system of equations by elimination. So again, we want to make sure that everything's lined up. So the x's are on top of each other, the y's are on top of each other, the equal signs are on top of each other, and the constants are on top of each other. So next, we want to look at the coefficients in front of each variable. So the x's have a 2 and a -2, which are opposites of each other, but then the y's have a 2 and a -1. But as long as one of them have opposite coefficients, we're good to go. So once we see that they have opposite coefficients, we can add downwards. 2 plus -2 would cancel each other out. That's the whole elimination part of the elimination method. So then I would take the 2y plus y, so it'd be like 1y, so I would have 3y. And 2 plus 4 is 6. So then I would divide both sides by 3, and y equals 2. Again, that's only half of my answer. I still need to figure out what x is. So I have the choice of substituting it back into either equation. I can plug it into the 2x plus 2y equals 2 or the negative 2x plus y equals 4. It doesn't matter. Last time we used the first equation, so let's use the second equation on this one just to show you that it really doesn't matter. So again, I'm going to put 2 in for y. I'm going to subtract 2 from both sides. Divide both sides by negative 2, so then x equals negative 1. So my final answer would be negative 1, positive 2, meaning if I were to graph these two equations, they would intersect at that point. Again, I would have gotten negative 1 for x had I taken that 2 and plugged it into the first equation rather than the second equation like we did. It doesn't matter which one you choose as long as you do it correctly. Moving on to example number 3, still solving the system of equations by elimination. So again, first step is to make sure everything's lined up. If you notice here, the x and the y are on top of each other and the y and the x are on top of each other. The equal signs and the constant terms are okay, but I need to flip one of these around. So in my opinion, it would just be easier to flip around the second equation. It doesn't matter. So I'd have 6x minus y equals 43. Keeping sure that the 6 was positive, it stayed positive. The y was negative, it stayed negative. So again, I'm just going to rewrite the first equation just so I can see the two equations together more easily. And now I see that everything is lined up. So then I'm looking for opposites. 6 and negative 4 are not opposites. Negative 1y and positive 1y, those are opposites. So when I go to add downwards, these should cancel. And let's get to that. So 6x plus negative 4x is 2x. Negative y plus y is 0, so those eliminate each other. And 43 plus negative 27 is 16. So then I would divide both sides by 2, and x equals 8. But remember, that's only half of my answer. I also need to know what the y value is of that point where the two lines intersect. So I'm going to take the x equals 8, and I'm going to substitute it back into either equation that we had from the start. It doesn't matter. I could even plug it into this equation that I got after I flip-flopped the 6x and the negative y. Again, it doesn't matter. In my opinion, I would say that it would be the easiest to plug it into the first equation since this y is just plus y. So then all I got to do is get rid of this number and then the y will be by itself. So I am going to take that x equals 8 and substitute it in for the x in the first equation. So I'd have negative 4 times 8 plus y equals negative 27. So negative 4 times 8 is negative 32 plus y equals negative 27. Add 32 to both sides. So then y equals 5. So my final answer would be 8, 5, meaning when I graph these two equations by getting the y by itself, finding the m and the b, the two lines would intersect at 8, 5. Again, you can always check your answer by taking the x value and the y value and substituting them back into the equations, and it should work for both equations. If they don't, then you did something incorrect. And finally, our last problem, example number 4, solve the system of equations by elimination. So again, our first step is to get everything lined up. If you notice here, I have x minus 4y equals negative 19. And over here on our second equation, I have 3y equals x plus 15. So our equal signs aren't lined up, our y's aren't lined up, our x's aren't lined up. But remember, theoretically, you are just putting it into standard form. So to get this equation in standard form, since the first equation already is, I would subtract the x. And remember, I want it so that the x's and the y's are on top of each other. So since the x is first in our first equation, I'm going to put that negative x in front of the 3y in our second equation as we're trying to get things lined up here. So I would end up with negative x plus 3y equals 15. And then just rewriting the first equation, x minus 4y equals negative 19. Now you can see everything is lined up, the x's, the y's, the equal signs, and the constant terms. Next, we're going to look for opposite coefficients. So we have negative 1x, positive 1x, so those will eliminate each other when we go to add downwards. And the y's will not, since they have opposite coefficients. So again, let's add downwards. Negative x plus x is 0, so those eliminate each other. 3y plus negative 4y is negative 1y, or you could just put negative y. And then 15 plus negative 19 is negative 4. So then I can get y by itself by dividing by -1, so I get y equals 4. Again, I have the option of substituting this y equals 4 into either equation, and I could also plug it into the equation that I got after I got the second equation in standard form to get everything lined up. It really doesn't matter in this case. I would just take this and substitute into the first equation because, again, it doesn't matter. Since I am solving for x, the x is by itself without a coefficient, so it'd be really easy just to get rid of whatever this is here to get the x by itself. So I would have x minus 4 times 4 equals -19. So that'd be x minus 16 equals -19. So when I add the 16 to both sides, I end up with x equals -3. So those are my two answers. So remember, write your answer as an ordered pair. So our ordered pair would be -3, +4. So if I were to substitute -3 in for x and 4 in for y into both of the original equations, it should work out since this is the shared point between the two lines. That's it for this section. Remember, this is just kind of an introduction to the elimination method, and we'll get into a deeper, more complicated elimination method in the next section, where perhaps when we have the problems and we decide to solve them using the elimination method, we will not start off with opposite coefficients in all the problems like we did in this section. So as always, make sure you jot down anything you don't understand so we can get that covered in class before we move on, and we'll see you then.